Let's take a closer look at some of these trigonometric identities. I'm going to start by analyzing the cofunction identities. Now here I've drawn a right triangle and I've labeled my angle theta in blue. I've also labeled the other angle in that triangle in red, and I'm mostly interested in how that third angle relates to theta. So I know that in a triangle, all three angles must add up to 180 degrees. So if I take theta and add phi, being that angle in red, and add my right angle, which is 90 degrees, I should get to 180 degrees. Now, if I isolate this equation for phi, again being just that third angle in the triangle, I'll need to subtract 90 and theta to the other side. 180 minus 90 is 90, and theta shows up there as well. So when we talk about these cofunction identities where we have 90 degrees minus theta, or pi over 2 minus theta if we're in radians, that really means we're just talking about the other angle that's inside a right triangle that contains theta. So that angle in red, that phi, is really just 90 minus theta. Now, let's take a look at just some of the basic trig functions. How about sine, secant, and tangent of theta? So sine of theta, it's equal to opposite over hypotenuse, which means that it's b divided by c. If I throw secant and tangent up here as well, I see that secant of theta is c over a, and tangent of theta is b over a. But let's change gears for a moment and think about that red angle instead. If I look at the red angle, b is the adjacent side and c is still the hypotenuse, which means that if I'm looking at this same ratio but from the perspective of that third angle, b over c is not opposite over hypotenuse, but is instead adjacent over hypotenuse. Meaning that that same ratio is the cosine of the red angle instead of the sine of the blue angle. I can look at similar things for these other two ratios as well. In relation to the red angle phi, c over a is the hypotenuse over the opposite side, meaning that this is actually cosecant of my red angle phi. And b over a would instead be adjacent over opposite if I look at the red angle. Adjacent over opposite is cotangent. So again, these cofunction identities are just looking at the same 6 basic trig functions, but from the perspective of the other angle that's inside of that triangle. Now, if we look at some of the details in these cofunction identities, a cofunction identity always relates a function to its cofunction. So it's going to relate sine to cosine, secant to cosecant, tangent to cotangent. So from a function to its cofunction. And in order to switch these around, we're also going to change from our angle to the complement of that angle. Since 90 degrees minus theta is the complement of theta. Same with pi over 2 minus theta is the complement of theta if I were working in radians. So a cofunction to a cofunction, function to cofunction, function to cofunction. And they work in the reverse ways as well, going from the cofunction back to the original function. So from cosine to sine, from cotangent to tangent, cosecant to secant. Next, let's talk about the Pythagorean identities. So it probably comes as no surprise that each of these identities come from the Pythagorean Theorem. So if we take a look at our right triangle again and set up that Pythagorean Theorem, we should have a squared plus b squared is equal to c squared. And what I want to do here is divide both sides of the equation by c squared. So just getting rid of the length of the hypotenuse. Doing so gives the equation a over c quantity squared plus b over c squared is equal to c squared over c squared. Now, each of a and b, regardless of which angle I want to talk about within this triangle, one of those must be the adjacent side while the other is the opposite side. It doesn't particularly matter which, just as long as I know that one is adjacent and the other is opposite, which means if I have a over c and b over c, one of those is the opposite over the hypotenuse, and the other is the adjacent over the hypotenuse. Meaning that one of these must come out to the sine of an angle theta, while the other works out to the cosine of theta. And c squared over c squared is just 1, giving us the first Pythagorean identity. To get the other two Pythagorean identities, I'm going to do something similar to dividing away c squared. But this time, instead of c squared, I'm going to divide both sides of my equation by cosine squared, giving me sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta. I can simplify each of those to get tangent squared plus 1 is equal to secant squared, which is that second Pythagorean identity. And for the third identity, if I take the original sine squared plus cosine squared as 1, and this time divide by sine squared, I get sine squared over sine squared plus cosine squared over sine squared equals 1 over sine squared, which I can simplify to 1 plus cotangent squared is equal to cosecant squared.